That's an interesting point, because there are so many theories out there, and all we can really do is base our decisions on the facts. And I find a lot in the scientific community, people, they're so hungry for an answer that they latch on to a particular theory, essentially blinding themselves of all possibilities in regards to the changes.
Well, look, Marie, when the Milankovitch cycles were created, when they came up with it, was in the 1920s. We didn't know much. We knew that there were ice ages, and we were really desperate to find an explanation for it. In the 1920s, the plasma physics was almost unknown. Well, it was known, but it was nobody really gave it much weight. And in the 1920s, we didn't have the ice core records. This is all that stuff that happened after the year 2000. Until the year 2000, until the space age, until we started taking measurements of the sun, and until we stuck our ice cores into Greenland and Antarctica, we really had nothing to go with. All we had is the sunspot cycles, and even those they didn't believe. If the sunspot cycles change, like we had the Maunder minimum with no sunspot cycles, then all of a sudden the sunspot cycles were back and were big, and the Earth get warm. So you have a correlation that the warming of the Earth came with the sunspot cycles. So why would you want to even look anywhere else? And then we saw all this reflected in ice core records. So we have now stuff on our hand, the evidence that wasn't available in the 1920s. That wasn't even, much of it wasn't even available in 2003. True. When Professor Dr. Zbigniew Jaworowski predicted, well, the interglacial is 500 years overdue. Get ready for it. That's all he could say. And he was an expert. He was doing ice exploration on 50 glaciers in 6 continents for almost a 50-year career. So he knew what he was talking about, right. That something was coming, but he didn't have the evidence. That didn't exist in 2003, but it exists now. And we tend to ignore. We spent 36 years to run that Ulysses spacecraft mission. And when the results came in, it didn't agree with global warming, so the mission was stopped and the team disbanded. So when all these discoveries we made don't agree with the global warming doctrine, it gets pushed under the rock. And that's one of the big problems that science has. And when you push all this stuff under the rock, you come back to the old thing, it's the Milankovitch cycles. And the Milankovitch cycles are really politically important because these cycles are based on the premise that the sun does not change. They take the sun as a universal constant, and they say the only thing that is changing is the orbit of the Earth around the sun. That's not true. The sun is changing rapidly and radically, and that puts the Milankovitch cycles out of the scheme. But if you're in the global warming camp, the global warming camp also says the sun is a rock-solid constant, and the only changes that causes the climate to change is not the sun. The sun doesn't change. It's the human being. Industrial development is the villain. So the Milankovitch Milankovitch cycles are somewhat related to the doctrine of the global warming, which both say that the sun is rock solid and everything else that we experience must have a different cause.
Yeah, I believe a lot of it is stemmed from political agendas. Now, the global warmists tend to say, they do love to blame everything on mankind, but on the other side of the scientific coin, they totally do not acknowledge the fact that the CO2 rise came after the temperature rise in historical records when you're looking at tree ring samples, ice core samples, and all that.
Yeah, well, when we have a warming trend, when the Earth gets warmer, you have more biological activity, and naturally the CO2 rises. Also, the oceans get warmer. When the oceans get warmer, they release more CO2. There's only about 2% of the total CO2 budget on the Earth in the atmosphere. The rest is dissolved in the oceans. So the temperature of the oceans has something to do with the emission of the CO2 from the ocean into the atmosphere. And the changes are small. But the oceans have warmed up. The Earth has warmed up since the end of the Little Ice Age. We have proof in the sun, in the increasing solar cycles, that we had 300 years of sun-caused global warming, and that global warming had some effect. It brought us more CO2. In addition, we do have the ocean conveyor belt system that brings dissolved CO2 from the polar regions into the Pacific, where it evaporates. And those have very long cycle times, around 300 years. It depends on where the source is. And what the CO2 rise, the sharp CO2 rise that we see now, also reflects the 300-year transport cycle of the CO2 dissolved in the polar regions coming into the Pacific and being released there. So it wasn't all caused by humanity, and it wasn't all caused by the Earth getting warmer. It also has something to do with that conveyor belt system that brings CO2 dissolved during the Little Ice Age now to the surface. So it's not a single cause, but the CO2 is nothing to worry about. It's not a greenhouse gas. It's a minuscule greenhouse gas, and
something like 0.04.
Yeah, I compare it to the World Trade Center tower that once stood. That is the greenhouse effect, and compare this giant building to a cat standing beside it. You won't even see the cat from any distance. Right. So minuscule. And even if you were to overfeed the cat to make it as big as a horse, you still wouldn't see it.
Gotcha.
So the CO2 has no effect.
That's a good picture to paint for people out there, because when we say that CO2 has such little effect, and you comparing a small cat next to the World Trade Center building, that's a pretty good picture to paint to give you the idea how important or not important that CO2 is.
It's not just sort of a fancy idea.
Right.
If you look at the CO2 absorption coefficient and compare this to water vapor, CO2 clocks in about less than 10%. And then if you look at the times at which the CO2 actually is active, the bandwidth, that is active only in very few narrow bands, whereas water vapor is active almost all throughout the entire spectrum. And water vapor is, well, is 4%, and CO2 is 0.04% concentrated in the atmosphere. So the numbers get smaller and smaller and smaller and smaller if you add them all up. So I said, how can you actually illustrate these tiny, tiny numbers in a rational manner? That's when I came up with the cat compared to the World Trade Tower.
That's good stuff. I've watched several of your productions, and the one that sticks out the most to me, Rolf, is your Ice Age dust video. I was wondering if you could elaborate on the correlation between this dust that they found, I assume, in ice core samples, and what does it mean for the Ice Age with this dust?
Well, I saw this dust appearing at the end of every Ice Age cycle. So I said to myself, what on earth can cause this dust? And then all of a sudden it dawned on me that the orbits of the solar system were actually supported by the magnetic fields of the primal field system. They're not just sort of mechanistically circling around the sun. There is something that supports that these orbits in a very orderly manner. But once these primal fields fail, that ordering factor is no longer there. Now, it wouldn't change the orbits of the Earth and the big planets in any way, because the momentum is so great, it just keeps going. But it would affect the orbits of small asteroids. An asteroid both the Earth and the asteroids, they fly through space, but space isn't empty. There is solar wind in there, there's solar dust in there, there's all kinds of little particles in there, and you experience this with satellites. Our satellites don't fly forever unless they get reboosted. But they run against friction in space, and the friction in space makes the orbits to decay. And if you don't have that ordering system anymore in the Kuiper belt, or also in the asteroid belt, where all these little asteroids are floating around, and they also, like our satellites, run against friction, and the frictions slow their orbit down because they're so small and they have such a large surface to go against this background in space. So I said to myself, well, if that friction reduces the speed of these asteroids, they come closer to the Earth, and after 45,000 years or 50,000 years, well, they could quite easily impact the Earth. And of course, most of them would disintegrate in the atmosphere. And that's where I think the level of the dust comes from. So it means to us, in summary, that yes, we do have primal fields out there operating, and when they are failing, they have some effects, and the failing effects prove that these primal fields do exist. That's what I try to convey with that video.
Okay. And like that was probably what I started off of my, like I had to watch that a few times actually, try to just to take in the information with current research that Mari and I do and the people that we've been in contact with. I don't think I could have even listened to your videos probably a year ago. I wouldn't understand most of it. But I always tell people that I recommend your work to, I tell them to take it slow and go over it many times. You will connect the dots.
Greenland and Antarctica, we really had nothing to go with. All we had is the sunspot cycles, and even those they didn't believe. If the sunspot cycles change, like we had the Maunder minimum with no sunspot cycles, then all of a sudden the sunspot cycles were back. We knew that there were ice ages, and we were really desperate to find an explanation for it. In the 1920s, the plasma physics was almost unknown. Well, it was known, but it was nobody really gave it much weight. And in the 1920s, we didn't have the ice core records. This is all that stuff that happened after the year 2000. Until the year 2000, until the space age, until we started taking measurements of the sun, and until we stuck our ice cores in the great.
They latch on to a particular theory, essentially blinding themselves of all possibilities in regards to the changes.
Well, look, Marie, when the Milankovitch cycles were created, when they came up with it, was in the 1920s. Right. We didn't know much. We saw.
That's an interesting point, because there are so many theories out there, and all we can really do is base our decisions on the facts. And I find a lot in the scientific community, people, they're so hungry for an answer that